continue to learn what we learned in the last class. It would be, I'll try to have it for two to 3 hours. This class will be somewhere around 2 to 3 hours. Okay, we'll try to finish the entire arrangement and combination concept, and then we'll move on to some new concept. In total, there are around 13 to 14 unique concepts in this particular topic. We'll try to cover at least the first 3-4 concepts today. Okay. And keep the rules simple. Turn on the videos. You have a question, you just unmute and ask. I won't be able to see chats every time. So if you're saying something in chat, I wouldn't know. So you'll have to unmute yourself and speak up. Okay. And someone asked the basic glossary. It's just the same what I think Rupal just mentioned right now. So it's what we did in the last class was just the basic of what is permutation, what is combination, when do we do permutation versus when do we do combination, major differences, basic formulas of NCR, NPR, and a couple of questions on the basics. Okay. With this, let's try to solve this question. Methodology is same. I'll give you guys 1.5 to 2 minutes to solve every question. You attempt it. Give me the answers in the chat box. You don't have to speak up the answers because other students would also be trying. And then I would ask methods to some of you, and then we'll discuss the solution and the different ways to solve every question. Okay. We try to focus less on the formulas and more on the concept so that in exam, you don't have to remember anything. Okay. And this is the most important topic because this helps you in your DILR section. It helps you in the number system topic. It helps you in your probability topic. So make sure you are very well thorough with this particular topic. Okay, there would be some, because in total, I have 150 to 200 questions from this topic. I will not be able to cover everything. I'll give a couple of it in the homework and then we can discuss it in our respective groups if there are doubts. Okay, please solve this. Number of 4-digit palindromes. For students who don't know palindrome is nothing but any number. So for example, any name is called as a palindrome. If I reverse the letters of that word, the word come out to be same, right? So any example? Can anyone give any example of a word which is a palindrome?
Naman.
Naman, right? You start from here or you start from here, the name remains exactly same. Right? Now here I'm asking number of 4-digit palindromes. Try it. Should be a 20-30 seconds question.
676.
Just type in your answers. No need to speak up. Others are trying. Till the time nothing is given in the question, you would always assume that the repetitions are allowed. That's an assumption. That's a fair assumption to make for your CAT exam. Okay, 676 is one answer. Number of 4-digit palindromes. Okay, time up. Someone is saying 99. Sai says 650. Raman says 81. Chalo, let's discuss. No, see, even here, this is not correct, right? It should be 26 into 26. Repetitions are allowed.
Okay.
So A, B, B, A. You have 26 ways to select A. Whatever you put here, same goes here. Then once you have put 1 in the first digit, then you have 26 ways again for B. And whatever you put here goes here. So it should be 576.
Okay.
Also, how did you get 650? How is 26 into 25 is equals to 650? What is this?
I did 20. I did 25 plus 1 into 25.
Okay, sorry, this is 676. My bad. Fair. Okay, thanks. We'll find. So question says 4-digit. Let me ask Raman, unmute and speak up. How did you get 81?
Initially 9 digits. At first place we can have 9 digits and second place also 9 digits as it can be repeated and then into 1 into 1.
Why 9?
Because it can be repeated now.
So why 9?
Acha, 10. 9 into 10. Okay. 0 can also
be 10, right? Because it's a 4-digit palindrome, you can't have 0 here. So you have 1 to 9 digits to be put in the topmost position. Then in B, you don't have any constraint. It could be anything 0 to 9. In total, 10 digits. So this is nothing but 10. So in total, 9 into 10 is equals to 90 is the right answer. Clear, everyone who did not get 90? Is it clear? Just say yes, no.
Yes.
Yes, sir.
Yeah.
So what if all the 4 digits are same?
It could be same, right?
Counted.
Yeah.
It is
It is
counted
also
in the 90.
also a palindrome. Hence, you're saying 10. in the in case of B, you're saying there are 10 possibilities.
Okay.
Okay.
Sir,
This
one
is
thing.
yeah.
Sir, in this case, we have like assuming the first digit should not be 0.
Yeah, it can't be, right? Because it's a 4-digit number.
Should we consider that also? Like, so the reason why I'm thinking is that usually, like, let's say we consider 4 numbers. So in those cases, we consider first letter as 0 as well. So
Okay.
like,
So
just
if
thinking
it
out
is
loud,
a
like,
4-digit number, you can't have the topmost place is 0. If there is 0 in the topmost position, you do not consider it in a digit. Like, it is a digit, but it is not a digit number. So hence, in scope of CAT, if it's a 4-digit number, don't consider 0 in the topmost position. Clear? If this is clear, please do this one. I want answers in next 10-15 seconds now. Can anyone let me ask someone who joined in for the first time? Braylon, can you answer? Braylon, Steindler.
So as of for 5 digits at place of 10,000, there has to be nine possibilities, and for 1,000 and 100 there are 10.
Sorry, can you repeat here? Like, this is an even palindrome, right? A, B, C, B, A. Now, which digit are you saying first of all?
For A there has to be 9 possibilities
Why 9 possibilities?
because you cannot put 0 there.
Okay.
Since,
Can you put 1 here?
yes.
Why? It's an even palindrome, right?
Oh, sure. I haven't saw even palindrome. I have done the solution for 5-digit palindrome only.
Okay.
So I haven't considered even.
Okay. So now that you have read it, how many possibilities are there for A?
2, 5, 2, 4, 2, 4, 6, 8, 3.
Yes. So in total,
4, so 4 possibilities you have.
okay. For B,
For B you have 10.
for C.
10.
So the answer is
400.
400. Okay. Now please solve the same question for odd palindrome. Come on, 5 seconds. Should not take more than 5 seconds now. The answer is 500, right? Because A would have 5 possibilities now, 1, 3, 5, 7, 9. B could be anything 0 to 9. C could be anything 0 to 9. Right? Now there could be a lot of cases, a lot of variants of similar question, but concept remains exactly same. Okay. Let's see how many of you can solve this. This is from one of your SimCat. How many times digit 3 appear from 1 to 1000? This is tricky one. Let's see who can answer this. By the way, before we solve, tell me one thing. In the number 30, how many times does digit 3 come? In this number 30, how many times digit 3 come? 3 times. Okay, Aditya. Aditya, digit 3. How many times digit 3 come? Simple. 1 time, right? You just have 3 here. But if my number is say 333, how many times digit 3 come now? It's 3, right? That's the only concept you need to take care here. That in some numbers it would be more than 1. In other numbers it would be 1 or less than 1 as well. Now try to solve. So see, how many times digit 3 appear here, right? Which means it's essentially either a 1-digit number or a 2-digit number or a 3-digit number, right? It's not a 4-digit number because 1000 does not have 3. So I can similarly say how many times the digit 3 appear from numbers 1 to 999, right? And now I can make some cases that, okay, we have 3 positions for 3 to come. If 3 comes in the 100th position, how many such cases do I have? I can have 10 digits here. I can have 10 possibilities here. So in total, I have 100 such numbers where 3 comes on the top, right? Which is essentially 3002 to 399. Now, there would be some numbers where 3 would come here. How many such cases are there? Again, I can have 10 possibilities here, not 9, because 2-digit numbers are also allowed, right? I'm actually saying from 1 to 999, and hence I would consider 10 possibilities here and not 9. So now it could be anything, right? Because 3 is coming at least once here. Similarly, I have 10 possibilities here. So in total, I have 100 cases again when 3 is in the 10th position. Similarly, last case when 3 is in the unit position, similarly 100 number. I have 10 possibilities here. I have 10 possibilities here. This number could be anything from a single digit number to a 3-digit number. So in total, 3 could come either in first digit or second digit or 3 digit. In total, I have 300 cases. The only doubt that comes here is, sir, here there could be one case where 333 is there, right? And still we are just considering them as 1. Ideally, they should be considered 3, right? Because topmost position is 3 here, 3, and if you have a 3 here, it should be considered as 3 and not 1. Fair point. But the only thing to think upon here is, see, you are already considering these cases in each of the 3 individual cases, right? So for example, 333 is already considered here. This is also considered here, and this is already considered here, right? So hence you don't have to individually count this case as 3. It by default gets counted in each of your case 1, case 2, case 3, right? And hence the total number of times the digit 3 appear would not really change. It would be 300 only. Is this clear? Any doubts or questions here? Please feel free to ask. This last one is a common doubt that should have come if you were not able to solve. That how do I sort of consider this? You don't have to worry about it. You just take care of 3 here, 3 here, and 3 here. Right? 3 can only come in 3 positions, and then count the total number of ways. The repetitions would automatically be up in the cases.
What about 1 to 99?
1 to 99, good. 1 to 99 is already considered in this case and this case, right? Because I'm saying 10 digits here. This has cases where the first digit is 0. You have 93. This has cases where 083, 073, 063 till 003. All of these cases are already considered here. Similarly, the second case also has cases from 30 to 39. So because I'm saying I have 10 possibilities here, I'm counting 0. You don't have to individually worry about 1 digit or 2 digit numbers. It automatically gets accommodated in your cases. So again, you don't again have to worry about 2 3s coming together because that already gets accommodated, right? Because yeah, fair point. So for example, cases like 133 should be counted twice, and this is getting counted twice. One is in case number 2 and second is in case number 3. 133 would come in both of these cases. So it automatically gets counted twice. Right? Because if you start going by that other approach, manually calculating, it would take you a lot of time. So there is an alternative to this. You start counting, yeah, 0 to 1000, sorry, 0 to 10 mein kitna aata hai, then 10 to 90 kitna aa raha hai, 100 to 199, and similarly, and so on and so forth. That's also a way you can use it. But again, it would take more time than this. If this is clear, I want you guys to solve this within next 10 seconds. Should be an oral question for the students targeting good 99 plus percentile in quant. You should try this orally without using pen and paper. 300, okay, Aditya, please check again. Rupal, please check again. Muskan, check again. You guys are on the right track, but just making some calculation mistakes. Janisha, I want you to explain this question. Are you done? Okay, so time up. See, again, simple question. I will again try to, first of all, explain how do we do it orally. It's a 4-digit number, right? Because 10,000 does not have 5, so we can get away with it. It's a 4-digit number. Any other digit could be 0, right? It's just that not all the 4 digits can be 0. Now let's consider the number as A, B, C, and D, right? Now, if I fixate 5 on the 10,000th position, if I fixate 5 in place of A, say A is equals to 5, right? Then how many cases can I have? B can have 10 values, C can have 10 values, D can have 10 values. So in total, 1,000 cases can be there when 5 is on the topmost position. Similarly, I have 4 positions for 5. 5 can be on the 3rd position, 5 can be on the 2nd position, 5 can be on the 1st position. In each of the cases, I have 1,000 cases, right? 10 into 10 into 10. So in total, it would be nothing but 1,000 into 4 positions for 5. Hence, the answer to this question should be 4,000. What are you saying? A, B, C, D. Now, ab batao Rupal tumhara case.
Sir, first case is 5 is on A position. So it will have 1,000 numbers.
Correct.
Second case में B का 5 है. So sir, A भी 10 पोजीशन लेंगे तो उसमें फिर वो फिर से काउंट नहीं हो जाएगा नंबर?
होगा और इनफैक्ट हमें 2 बार काउंट भी करना है, राइट? बिकॉज सी अगर यहाँ पे 55 है और यहाँ पे 55 है, 5 कितनी बार आ रहा है? 2 बार आ रहा है, राइट? सो 5 नीड्स टू बी काउंटेड ट्वाइस.
यस सर.
इसको सिंपल यू कैन सी कि हाउ मेनी टाइम्स डिजिट 5 अपीयर फ्रॉम से 1 to 100. So it's a 2-digit number. I would say 5 यहाँ पे. So there are 10 possibilities here. 5 यहाँ पे. So there are 10 possibilities here. In total, I have 100 possibilities. Sorry, 20 possibilities, right? At 10 plus 10. Now, if I have to go and cross check this, what would be those cases? 0, 5, 1, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5. अभी 5, 5 को भूल जाते हैं. 6, 5, 7, 5, 8, 5 and 9, 5. 4, 5. These cases, right? Did I miss anything? Correct. Then what are the other cases? 5, 0, 5, 1, 5, 2 till 5, 9. Right? So in sub में 5 is actually coming once, right? यहाँ पे भी 5 is coming once except the number 5, 5. जहाँ पे it is actually coming twice, right? So in total 9 plus 1, 10 times is 5 coming here and 9 times, sorry, 10 plus 1, 11 times 5 is coming here in the second case because 50 to 59 10 number है, हर number में 5 first place पे है, so that's 10. 55 में 5 is counted 1 extra, so that's 10 plus 1, 11. ऊपर में we have 9 cases, in total 20 cases, and if we do it by this method it also comes out to be 20. So you can always validate, derive your own formula by shortening the size of the question. पहले 1 to 10 के लिए कर लो, 1 to 100 के लिए कर लो manually. Try to identify the pattern and then extrapolate it to 1 to 10,000. Yeah, so Rupal was asking the question that if I consider A as 10 because there are 10 possibilities, and if I consider B as having 10 possibilities, there would be cases when 5 is getting repeated because I can have 5, 5 here and I can have 5, 5 here. So should we not remove it? Was her question. So what I explained is we need to consider them twice only because we are just calculating the total number of times in which 5 comes. So it has to be counted twice if there is a 5, 5 possibility. So we don't have to subtract them. Right? So let me ask this question to you. In how many numbers digit 9 appear at least one from 1 to 1000? Similar question, but let's see who can solve this now. In how many numbers the digit 9 appear at least once? I'll give you 1 minute for this. Aditya, Rupal, okay, 300. I'll just advise you guys to read the question again. There is a trick here. What I'm asking is, in how many numbers digit 9 appear? Prelan, you may want to try it manually as well. Like, how do you calculate cases here? No. So, abhi to Milana, I'm not even asking about the solution. I'm just trying to ask, what is this question talking about? Is it same as the last question? If not, what is the difference here? Like, a question में क्या पूछा है?
Sir, question speaks as in that question, we need digit 9 at least once, or we can have more than one time, right?
Okay, good. Yes. What does that
We
mean?
need for all those cases.
So this means that the case of 99 will be counted only once and not twice, because if the number is 99, it is only counted once and not twice.
Yeah.
Right? Fair. Okay, so good attempt. Can anyone explain me how do you solve this question? Maybe students who tried it, say Akanksha, if you can just explain, how did you get 300?
Sir, it means like for 99, 299, 399, we should count only once.
199, 299. Now, why are you asking this to me? In how many numbers digit 9 appear at least once? So in 199, would you count it as 1 or 2? Question says, in how many numbers digit 9 appears at least once?
It is to be counted as 1.
Exactly. Because you're just counting the numbers where digit 9 is there. Whether it's once, twice, thrice, I don't care. But wherever digit 9 is there, we just have to count it once. Right?
Okay.
So I think enough time spent will directly jump on to how do we solve this. So what we did last time is, see, this question says in how many numbers digit 9 appears at least once. Means it could be either once or twice or thrice. Either I can make 3 cases, total number of cases when digit 9 appears exactly one, then total number of cases when digit 9 appear exactly twice, and then appear exactly thrice, right? But then again, there would be 3 cases. Or can I do that, okay, total number of numbers possible, like total numbers which are possible minus when there is no 9, right? So how many total numbers do I have from 1 to 1000, and then I'll just remove the cases where there is no 9. So by default, I'll just remove 1000 because 1000 is not there. So my new question is from 1 to 999, how many numbers are there in total? I have a total of 999 numbers, right? These are my total number of numbers. Now I just need to remove those cases where digit 9 is not there. So if I don't want digit 9 here, I have 3 digit numbers, right? A, B, C. A can't be 9. Rest A can be anything. So I have 9 possibilities here. Similarly, B can take any value from 0 to 8. I have 9 possibilities here. C can again take any possibilities. C can again take any value from 0 to 8, right? Because I don't want a 9 in either of the places. So again, I have 9 possibilities here. In total, it's 9 into 9 into 9. But there's a catch here. Can anyone tell me what is the catch? Right? So of course, see, there are multiple ways to solve it. Ideally, whenever question says at least once, it becomes easier. Here, total number of 9s mein kya hoga? There would be some numbers where 9 is not there. There would be some numbers where 9 is exactly 1. There would be some numbers where 9 is exactly 2 and where 9 is exactly 3. These are the only 4 cases, right? Now, if the question tells you when 9 is exactly 1, then what do? Either you say 9 exactly 1 or 9 exactly 2 or 9 exactly 3, individually calculate these cases, or you simply say total minus where 9 is not there. Total number of numbers are 999. I'm not counting 1000 because 1000 with a 9 hai nahi, so it doesn't even make sense for us to count it. We'll just have a 3-digit number. So how many total 3-digit numbers do I have from 1 to 999? 999 numbers are there. How many such numbers are there from 1 to 999 which does not have 9? We just said it. It is 999. But here there's a catch which some student mentioned, that 000 is also
Yeah, what
included,
about 0?
right?
Yeah.
But 0 ideally should not be possible. So I will have to subtract 1 from here. This is clear why we are subtracting 1, because there is a case where 0 is also included, but ideally I wanted to calculate numbers from 1 to 999. Hence we'll subtract that. If you solve it, you will get what? 999 minus, what is this?
729.
Plus 1. So this is nothing but 271. How many of you is clear with what I just did?
But
so let's take that as like method 2. Okay? So method 2, let's try to solve it by manual calculation. Fair. So everyone tell me, if you say from 1 to 99, how many times or how many numbers have 9 in it? See 09, 19, 29, 39, 49, 59, 69, 79, 89. So from 09 to 89, you have 9 such numbers, plus 90 to 99, you have 10 such numbers. So in total, can I say I have 19 numbers from 1 to 99 where digit 9 is there? Now similarly, please pay attention, this is very important. This was 01 to 99, right? Similarly, 100 to 199, 200 to 299, we'll also have 19 only, right? Because first digit is like 1, so we can get away from that. So 100 to 199 maybe 19 times hoga, 200 to 299 maybe 19 times hoga. Similarly, 800 to 899 tak 19 times hi hoga, right? So in total 01 se lekar 1, 2, 3 till 8, we have a total of 9 cases, right? So can I say ki from 001 to 899, 9 has come at least 19 into 9 equals to 171 times? Because first 100 numbers mein 19 times aaya, then next 100 numbers mein 19 times aaya till 900. In total, I have 9 such pairs. In every pair, I have 19 possibilities of having 9. So in total, 19 into 9 is 171. And then I will take 900 to 999. इसमें तो there are a total of 100 such numbers, right? And every number has 9 in it because 9 is my 100th digit. Whether it comes once or twice or thrice, I don't really care, but it's there, right? So can I say 171 upar wale plus 100 this? So in total, there are 271 such numbers. Is this method also clear to you? ABC mein you'll have to exclude individual pairs ki where 9 comes twice and where 9 comes thrice. What you can also do is here case 1 where 9 comes exactly once, right? So it is 9 this, 9 this, or 9 this, right? So
Yeah.
how many such cases do you have where 9 comes exactly once? If 9 is here, you can have any 9 digits here except 9. Again, you can have any 9 digits here. So it is a total of 81 cases. Similarly here, similarly here. Clear? Is everyone clear with these two concepts? Last question, we were counting the number of digits. Here we are counting the total number of numbers. That's the difference why this answer would always be less than that, because we won't count the digit twice here. Perfect. Then I want you guys to solve this within next 15 seconds. Come on. And okay. Well, see, fairly simple. In how many 4-digit numbers? In the interest of time, I'll just solve it for everyone. Again, you don't have to do manual calculations and all, but okay. It's a 4-digit number, A, B, C, and D. Digit 5 do not appear at all, right? So how many possibilities? Again, in the last class, I've explained, we always start from left to right and not from right to left. Always left to right, so we'll start. So we'll start from A. A can't be 0 because it's a 4-digit number. A can't be 5 as well, right? Because I don't want 5 here. So out of 10 digits, 2 digits are gone, which means I only have 8 possibilities here. Similarly for B, repetition is allowed, but B and C and D can't be 5. So I have 9 possibilities here. I have 9 possibilities here, 9 possibilities here. Answer is 8 into 9 into 9 into 9, whatever that is. So solve and mark it as the answer. Let's solve this. In how many ways can you arrange the word attitude? Again, fairly simple. You don't have to calculate, just give me the expression. So you just have to form all the numbers using the letters here. I have A here, I have T here, I have I here, I have U here, I have D here, I have E here.
So there are 8 positions, right?
Correct. 8 positions are there.
So number
we can
of
shuffle
ways in
them.
which we can shuffle is 8 factorial, but actually it should not be 8 factorial because we have repeated letters.
Very good. Yes.
So I guess it should be 8
Well,
factorial. And
let's take a simple example, right? Let's say we have a 3-digit number ABC. How many total arrangements can we make? We can make ABC, we can say ACB, BAC, BCA, CAB, and CBA. In total, I have how many possibilities? 6, which is nothing but 3 factorial because all the letters were distinct. Second case, when say 2 letters were same, say number was A and B. Okay? Now, in that case, what happens? Let's just replace B with A. A, 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 replacing B with A, replacing B with A, replacing B with A. Now see CA, CA, the last 2 cases become exactly same, right? This case ACA and this case ACA becomes exactly same. Similarly, the first and the third cases become exactly same. So in total, I only get 3 cases now and not 2. Which means if there are, say, 2 repetitions in a 3-letter word, the total number of possible arrangements is what? First of all, you assume all the letters to be distinct. You have 3 letters, you arrange them in 3 factorial ways. However, because there are 2 letters that are same, you do a division by 2 factorial, which are the same number of letters. Fair? Hence, if you solve this, the answer comes out to be 3. Now, similarly, if you have A, B, B, in how many ways can you possibly arrange them? Again, you would initially assume all the letters to be same. Sorry, all the letters to be different. It's a 4-digit word. So in total, 4 factorial. However, because these 2 are same, you will divide this by 2 factorial. Similarly, because these are also 2 same, you will again divide it by 2 factorial. So the answer is nothing but 24 by 4, it's 6. Again, you can individually make cases and solve it. Now applying the same concept here, can all of you please try this particular question again and tell me the total number of arrangements? 8 factorial by 3 factorial. Very good. Everyone else who answered something else, is it clear why it is 8 factorial by 3 factorial? Correct, because T is coming thrice and rest all the other letters are coming once. So this happens.